Hi, I'm Mark Pond. Welcome back to part 2 of our discussion of robots for First LEGO League. I'm going to go through, in this section, we're going to talk about attachments and sensors. In large part, a robot's job in a competition is to carry attachments that do the missions and use sensors to get there. So if you consider the robot as designed to carry sensors and attachments, that's pretty much it. Now I'm going to go through the sensors first, what you'll see, and then I'm going to try and show you a few attachments. I don't want to go too crazy. This is my demo robot, and I have all kinds of attachments here. None of these are mission specific. This is all demo. So I hope you get some good ideas here. I hope you and your kids get something that you can use. Now there are different kinds of sensors. This one, this is the color sensor. Cable attachment on the back. Typically they mount on the bottom. Color sensors can be used in this configuration in the robot as a line follower. That's a typical use, but you can also use them. I've seen them used to stop at a certain color mission model, or in some cases even the kids use different colored Lego bricks to wave in front of a color sensor to initiate a program. I thought that was pretty inventive. This particular one is designed as a line follower. And you'll notice, this is just a little tip, these are the drive wheels, here are the sensors. A lot of times you'll see when a team has decided to use a color sensor as a line follower, they put the color sensors way out here, away from the axle, the center line of the axle. Well, you want the sensors to be as close to the center line of the axle as possible, because as soon as they detect a change in the color, they tell the brick to tell the motors to turn. So if they are far ahead of the motors are going to turn the robot before the line turns. So you want to make sure, if you're doing a line follower, to have the color sensors as close to the center line as possible. Another sensor that you'll see a lot is the ultrasonic sensor. Kids get a kick out of this because I guess it looks like a cartoon character. Hold it back a little bit so maybe you can get a better view. This one works by sending a signal from one of these eyes and receiving it in the other eye, or what appear to be eyes. Very consistent, very reliable. We've used these for years. The most common usage is to have them mounted on the robot, as you can see here. I hope you can see here. And you can use it to determine the distance the robot has traveled from, let's say, the wall before making a turn or executing something, or to stop a certain distance short of the wall before making a turn or doing something. The one caution I would give you about the ultrasonic sensor, you'll notice that I have this in back a little bit from the bumper. If the ultrasonic sensor gets too close to a flat surface that you're using as a guide, let's say to a sidewall, there isn't enough room for the signal it sends to be received by the other sensor, or by the other eye. So it will tell itself it's infinitely far away because it's not receiving the signal. So if you want to use the ultrasonic sensor to pull a certain distance away from the wall, your first move should be programming the robot with rotations or time or something to get a certain distance away from the flat surface so that it can read a distance. But it's very consistent. I've had good luck with this. Another sensor is a touch sensor. You notice it has the red device in front that reacts to touch. It doesn't need to be clobbered, it just needs to be touched. Very reliable. I've seen these used to bump into a flat surface, a wall or a mission model, and send a signal to the robot to do something. I've also seen it used, kids use it to touch to initiate a launch, to leave base and start a whole program, which I think is a pretty neat app. Very reliable. Last sensor is the gyro sensor, sometimes mispronounced gyro, especially in one tutorial online. The gyro sensor is tricky. For a couple of years I didn't use it till I found a kid who could program it and explain to the judges how to program it. What you don't want is to have a program that the kids can't explain to the judges. The gyro sensor can be used to keep the robot in a straight line. You don't want to run the robot too fast because sometimes the momentum carries it beyond the ability of the gyro to correct. It will give a consistent turn. Sometimes you need to do a little trial and error to make sure that you're getting the turn that you want. There are some tutorials online for the gyro sensor. Just again, be sure that your kids know how to explain its use, even in kid language, to the judges, because what you don't want is to have a kid say something like, "I don't know how it works, Dad programmed it." That would not be good. Those are the sensors. One of the things about the gyro sensor that I like is you can put it pretty much anywhere, as long as it's aligned with the direction you want it to go. Sometimes a gyro needs to be recalibrated. The easiest way to recalibrate it is to disconnect it and reconnect it. When you do that, it sets itself at 0 and it'll stay there. There are programs you can use to put in your overall program to recalibrate the gyro. Those are pretty good, but when you're starting out, I tell the kids, line the robot up with what you want to be 0, disconnect it, count to 2, reconnect it. Works like crazy. One of the things you're going to want to learn how to do that's difficult to show in this particular video session is you're going to want to learn how to use the Port View application in the brick. Port View. It's one of the tools. There are tutorials online. You can Google EV3 Port View or First Lego League EV3 Port View, and there are tutorials that will show you how to use it. The Port View will help you determine exactly how many rotations or degrees of rotations motors have turned, or it will tell you what the sensors are reading. You can use the Port View to tell you what the ultrasonic sensor is telling you is the distance from a wall or a flat surface. You can use the Port View to read what the gyro is telling the robot. Learn to use the Port View feature on the brick. Now, attachments. There are two kinds of attachments. Passive and motorized. Passive and active, call them what you like. I prefer passive and motorized. That's not written down anywhere. This particular attachment was used by one of my teams a number of years ago in the Trash Trick series. No motors. This is about as simple as it gets. We had I hope this shows up, we had a peg in the frame, in the chassis, and the kids would mount this attachment so. And it was intended to push a truck in Trash Trek. It worked every single time. It worked in practice, it worked in tournaments, it worked at Legoland, at the International Open. It never failed. Attachments don't need to be complicated. This thing's a beauty. You can get as complicated as you want to get. This particular one of the kids did some research and came up with this. We have a few different versions of it. We can now call it by his name. I won't mention that name. But we named this attachment after him. This thing we used this a couple of times. Again, you can go as crazy as you want to go, or as simple as you want to go. If you're going to use a motorized attachment, normally what you use is this motor. This is what Lego calls the medium motor. Oh, one of the things you'll notice, and this is backwards in this video, I always write the date when we buy a replacement motor, just so I know which ones are older and which ones are younger. Personal thing. Nobody cares if you just write something on here in a Sharpie. The medium motor, as opposed to the large motor that's usually used as a drive motor, the medium motor is longitudinal. The axle comes out the front. It has mounting points on the sides. It also has mounting points here where you can mount a beam on the front and an axle can go through it. A relatively typical configuration for, especially for new teams, is something like this, where you see the motor mounted to the chassis, axle in the motor, arm mounted to a gear, something like this, and the objective is for this to lift something. Nice and simple, pretty reliable, it works, but the problem with something like this is it's not very sturdy. You have a lot of play in it. What I prefer to do, if I'm going to use a motorized attachment, is something like this. And I hope you can see these. What we've done, this particular motor is mounted vertically. It turns an axle here. We have a gearbox here. That gearbox is attached to the frame, attached to the chassis, if you will, and the motor is attached to that. This is sturdy. We're using the gears in the gearbox. This particular one, we're using bevel gears to turn. We can operate 2 attachments with 1 motor. First Lego League rules maximize 4 motors at the table. If you get 2 attachments, we'll go into what kind of attachments in a moment. This helps. You'll notice I have a crank here. This is a Lego part. You can use that. The first thing that a kid will do, if you use the arm and then you want to reset it. See, in this particular config, a kid and sometimes an adult will just grab it and push it back. Well, that's tough on the works. It's tough on the parts. I prefer to crank it back. If you have a crank like this, you can use that. Lacking that, you can just put a gear on the axle and use your fingers and turn that. So you can reset the motor. I like to have it to be sure that every time we start a mission, the attachment motors are exactly in the same place. If you're going to raise a motor a certain distance to accomplish a certain mission, you want it to start in the same place every time. So I reset it using the crank. Again, you'll notice in this one we have a gearbox. Now this particular gearbox uses a worm drive attached to this gear. One of our kids, we named this one after one of our kids too. He did some research and came up with it, and we use these things like crazy. One of the great things about gears is it gives you a certain degree of precision. If you go from, gears will do a couple things for you. They trade speed for power, power for speed, change direction. In this particular case, turning this smaller bevel gear to this larger bevel gear, turning this worm drive, if we need to adjust this arm to a very precise position, we can do that with this motor, with this medium motor. Medium motor, again, attached to the gearbox. Gearbox is attached to the frame. This thing's pretty sturdy. Sturdy is what you want. Now, one of the things that I like to see in attachments is what I call, what a lot of people call, a quick connect, quick disconnect. There's several different ways of doing that. You saw how I showed you in the beginning of this conversation, this part that we used in Trash Trek that works so well. you use an axle or a rod, call it what you like, into this part here. I don't know what Lego calls this part. I love these things. This enables you to attach a couple of beams together. You slide it into 2 holes. You can push just about anything on the table with this. Very good setup. You can also, if you like, use something like this. If you put this in the arm of the gearbox, and if you have something that requires something like this to lift it, you can use one of the little T parts. See how that's set up? This slides right into here. It works. Bring it back to launch. Take this out. You take another one. Again, you have the T that fits into this slot, and you close like this. Now when you use a quick connect, quick disconnect attachment, you give up a little bit of sturdiness in the tool itself. So you have to make a decision. Do you want it to be sturdy by attaching it firmly with the either the blue pins or the black pins? That's sturdy, but maybe it doesn't do what you want. So you have to make a trade-off. But one of the things that I have found is that these black pins, and there are other colors, I'll use the black pins as an example, that hold the pieces together. If you want your kids at a tournament to take 2 pieces apart that are held by those black pins, there's a pretty good chance that those pins aren't going to do what you want them to do. If one of them hits the floor, you're never going to see it again. So I try and avoid having kids take things apart and put things together while the clock is running at a tournament. Too many things can go wrong, and I've just seen too many failures because of that. So I like to use the quick connect, quick disconnect. There are several ways you can do it. One of the things I like to do, and I'll show you with this part here, if I can get this out here where I think you can see it a little bit. This is a fairly simple setup. And the way this works, let's say you need a bumper. You would use something like this. This would slide into here, and then you would use a pin similar to the one we just looked at a minute ago. In this case, we'd use 2 pins mounted here and here. And that way we have this bumper. It goes out and bumps, pushes, does whatever you want it to do. Comes back to base. The kid takes out these 2 pins, sets this one aside, and then gets this one, which you have ready. One of his friends has ready. And you attach it the same way. Now gravity is not helping me in this demo here. Bear with me. And then this particular attachment, if you need a rake type setup, let's say to pull a lever. There's a lever fixed on a horizontal lever fixed on the mat. You go this way, come back, pull it, do what you need to do, and then raise this out of the way. Come back to base, or home, or launch, pull the pins out, set that down, put the next attachment on. You'll notice back here in the back, going back to this motor, these are called dog gears. Dog as in the family pet. Not what I named it. It's what the kid on YouTube, fellow calls himself Builder Dude. If you go to YouTube and search for FLL Builder Dude, You will see umpteen tutorials from this young man, who's probably very wealthy by now. I like to use the dog gears. Where's a good example? Let's use this one. You see, this particular fitting right here goes right into the dog gear. Let's try it on this side. There we go. Goes right in there. This piece down here at the bottom slides there. The gears mesh. You take two connecting pins. Believe me, the kids do this a lot faster than I do. And presto, you have your scissors. To reach out and push something and come back. When you're done, you pull the two pins, take it off, put on the next one. Again, not my invention, invented by a kid. One word of caution. These pins, these quick connect pins that I like a lot, that we use a lot, you will tell your kids, don't lose the quick connect pins. They will then go out and lose the quick connect pins. They are kids. So we have a bunch of them. And I have put places on the robot where we carry them. So hopefully we won't lose any more of them. Now, I understand that after these videos are watched, we're going to have a question and answer session. I'll be more than happy to answer any questions you have. I'll be more than happy to send out photos, diagrams, video, whatever I can to help you. But what I think will help you the most is let your kids start playing with it. They will come up with better ideas. All these ideas are kid ideas. And they'll come up with something better than us weary old adults can. So, with that, I thank you for your time, and thank you for watching, and I look forward to hearing from you in the question and answer session. Bye-bye.